Okay, so now let's move on to question 4. So here in question 3, we used the arrow method, right, to find the relationship between revenue and the category of elasticity for those consumers, right? So basically, if the consumers are inelastic, facing a price increase, the revenue will increase for this firm. And if the consumer is elastic, the price increase will lead to revenue decrease for this firm. So now let's look at this line. Okay, this is a demand. This is demand line, actually inverse demand line, because P is here. Okay, all right. P is here in the vertical axis. Okay, so for a line like this, where we will have the slope, right? For a line, the good thing is the slope is fixed. So here, then we're going to utilize the slope version of elasticity, which is delta Q over delta P by P over Q. Right? So for this line, its slope is actually delta P over delta Q. Remember, it's delta Y. It's delta Y over delta X, and Y is the vertical axis, and X is the horizontal axis, right? But this being fixed, and this is fixed for a linear case, for a linear case of demand. But delta P over delta Q is fixed, then its inverse, which is delta Q over delta P, this one is fixed as well, right? Then along the line, the elasticity of each dot is more hinged on the value of P and Q. Okay, so because previously our discussion is on price increase, and here from A to B the price is increasing. So let's just have our discussion along this trend, okay, from A to B. So let's look at those two extreme points, two endpoints. At point A, right, price equals to 0, Q equals to some value, some constant, some constant. Okay, then what's the value of elasticity? This is a fixed value. Here, this is a constant. P equals to 0. So here, then it's a certain thing multiplied by 0. The result is 0. So at point A, we have a perfectly elastic case. Okay, and then let's look at point B. At point B, P is at a certain P equals to another constant. Okay, but Q equals to 0. Then what's the elasticity? The elasticity here, this is a fixed value. P is a fixed value, right, which is the height, but Q is 0, right? So in this case, it's certain value with the 0 in here. Right? So the result is negative infinity. Negative, that is because it's a demand. We know its sign is negative, but the key is it's infinity. So here, sorry, previously it was perfectly inelastic. And here with the infinity elasticity, it is perfectly elastic result. Okay, so here in A, it is perfectly inelastic. That means as you're increasing your price, revenue should increase, right? So coming from A along here, your height, which is price, is increasing, so your revenue should be increasing, right? But near B, right? If you increase your price, near B, if you increase your price, now you're at the elastic part, because B itself is a negative infinity of elasticity, right? You're close to B, then the still very elastic. Price increase, revenue should decrease. Going this way, right? So here, moving along, if we find the unitary elastic point, say point C, then on the unitary elastic from A to C, where the consumer is inelastic, you can raise your price to increase revenue. Your revenue should increase all the way. Then from C to B, where you are more elastic, and here you're more inelastic. From C to B, your consumer are more elastic now. As the price increases, revenue decreases. Right? So your revenue keeps increasing, and at point C, which is unitary, show here, say from point A, right? And here it is price. At point A, price is 0, right? From point A, your revenue is increasing. At point C, it should be here, and then after point C, your revenue will keep decreasing. Therefore, point C is the place where your revenue is maximized. That's why we are using unitary, and point C is the watershed between elastic and inelastic, which is unitary elasticity. And this watershed point is also the point where the revenue is maximized. Okay, so now let's just use this conclusion. So here C, where elasticity equal to 1, we reach maximized revenue. Okay, now let's look at question 4 on the sample question sheet. Okay, so for the demand function, Q4, for the demand function where Q equals to 100 minus 3P, let's find the P and Q that maximizes the revenue. So to maximize revenue, okay, elasticity should equal to 1, and here elasticity is delta Q over delta P, by P over Q. And in this case, to find the delta Q over delta P, we need to look at the the slope term, which is minus 3, and we need to discern what does this minus 3 represents. It represents delta y over delta x, and in this case, your Q is y, your P is x, so it's delta P over delta Q. So we can just plug this directly in. We don't have to inverse it. Multiply by P over Q, and here it's just easier for us to simplify this by only leaving one unknown. So here Q can be expressed as P, right? So it's 100 minus 3P. That's your Q, according to this formula. So now we just need to solve this result, right? It is 1 equals to minus 3P over 100 minus 3P. and we can multiply the bottom to the other side. So it is 100 minus 3p equals to minus 3p. I apologize. I forgot to add the absolute value sign, right? Because here we wanted it to be unitary elastic. However, in this case, to have this being unitary elastic, you need to apply the absolute value to it. So I need to apply the absolute value. So here it is actually positive 3p equals to 100 minus 3p. So it's 100 equals to 6p. P equals to 100 over 6, which is 50 over 3. And then you can plug this P back into this equation to find Q. So Q equals to 100 minus 3 times of 50 over 3, and the 3 cancels, which is 50. And these are the P and Qs that maximizes your revenue, utilizing the unitary elasticity feature. Thank you.